Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We are from Group 6, Group Extraordinary. So the purpose of this video is for our CAPSTONE project midterm design review for our groups Banu Musa Smart Solar Home. So I am Nur AFIQAH binti RAZMAN, metric ID 1141X76. I will talk on our project executive summary and objectives. Next, I will also touch on proposed methodology for power scheduling part of our project. So first one is the executive summary. Our Earth cannot sustain the continuous increased consumption levels with drastic growth of population while having limited resources. So one of the biggest issue that this Earth currently facing is the energy depletion. In order to prevent worse consequences of energy depletion to our Earth, certain efforts should be taken. So, the first one is the development of renewable energy to overcome this limited resources issue. Example of renewable energy are solar energy and wind energy. Second is by energy conservation. Thus, we introduce to you our project Banu Musa Smart Solar Home. So, next one, proceed to energy management power scheduling part. So, proposed methodology. For this part, we are working on developing a program that will display warning and alarms user if the reading of the total power consumed exceed maximum power consumption that we set. So, as you can see here, we want to create an energy calculator. By using this energy calculator, reading of total power usage was measured and taken. So, two possible outcomes from this reading are either if exceed maximum power and if not exceed maximum power. The first one is if exceed maximum power, it will display warning alarm. So, and if not exceed maximum power, it is possible for user to use other appliances. Next one is isolated DC-AC converter. This is the house appliances lot. So we arrange the load according to the space. For example, load 1 is living room, ceiling fan, LED bulb, CFL bulb and other electronic appliances. And for example, other example is load 5 is toilet. So we have CFL bulb and water heater.
Okay, Bismillahirrahmanirrahim. My name is REDZA bin Abdul Halim and I'm going to continue with the current stage of power scheduling. For our group, we actually managed to illustrate on how the power scheduling system will work on the MATLAB. And the system that we designed actually got 6 types of buses and 1 main system. And how the system will work? The system will work whenever the user want to use the appliance, they only need to press the button where got the name of the appliance. For example, if the user want to use the ceiling fan at the living room, they only need to press the button of the ceiling fan, and then once they press the button, the bus will send the power consumption for the appliance into the main system. With that, the main system will calculate the total power of the total power consumption for all buses under two conditions. Okay, the first condition is if the total power consumption exceed 4.8 kilowatt, the main system will trigger the alarm where to warn the user to not use to reduce the usage of appliances. And then for the second condition, where if the total power consumption are less than 4.8 kilowatt, the system will allow the user to use other appliances. Yes, that's all for current stage of power scheduling.
Okay, Bismillahirrahmanirrahim. My name is Muhammad AMIRUL and now I will discuss with all of you about the control of temperature. Okay, so let's proceed to the current stage. This is the coding that that I am doing now, which is there is some improvement rather than before, which is the coding for this time is was developed for all 3 sensors compared with before, which is the coding is all about 1 sensor only. This is the circuit looks like, and which is the circuit was completely installed. Okay, if we compare what the upgraded work if from now and before, which is in previous there is no coding then, and now nearly 50% coding was completed. Secondly, the compartment were bugged before, and then now the circuit was completely installed. And third, the circuit was connected with only one sensor, and now the circuit connected with all three sensors. And lastly, the coding with only one sensor, and now the coding with all three sensors in developed. So let's proceed to the encountered issue. There is some problems that we face, which is there is no LM35 library in Arduino. So for suggested plan, we should download the LM35 library in the Arduino so that we can run the coding. And secondly, insufficient fan to implement in the circuit. Since we have an insufficient fan, so that we replace the fan with the green LED. For the future work, we decided to upgrade the system in terms of its functionality, and then we decide to implement Bluetooth slot in the system. I think that's all.
Assalamualaikum warahmatullahi wabarakatuh. My name is NABILAH bin Ismail. I'm going to explain about the air quality control system since I am responsible for that part.
Figure 1 shows block diagram for the developed devices. From our previous preliminary design review, we decided to use air quality MQ135 in our air quality system. We have stated that our air quality control system will have 4 outputs. The output are LCD, exhaust fan, window, and buzzer. Okay, let's move on to the flowchart for the detector circuit. When the air quality sensor starts to sense the surrounding air quality level, the analog signal from sensor need to be converted to digital signal via Arduino Mega. Then the LCD will display the air contaminant level in part per million unit. If the air contaminant level reach 100 ppm, the exhaust fan will automatically switch on, the servo will rotate 90 degrees to indicate window is open, and buzzer will emit sound. Okay, for the encountered issue, on comfort condition part, we only have budget issue. For the air quality control system, we decided to assemble the system for a room only as a prototype because of the limited budget. For the temperature control system, we managed to assemble the system for 3 rooms. Okay, for the suggested plan and future work, we decide to combine the temperature control system and air quality control system into one main system so that the system can work in efficient way. And we decide to design our own architecture for the prototype house to reduce formaldehyde produced from manufactured wood products like beds, desks, and kitchen cabinets. And lastly, we plan to include Bluetooth module, HC05 module in our system and use PIR sensor to make the sliding door in the house to automatically open and close when motion is detected.
Okay, now let's watch how the air quality system in our house works. When the air contaminant level exceeds 100 ppm, the servo will rotate 90 degrees to indicate that the window is open. The buzzer will emit its sound, and the fan will spinning, and the LCD will display the value that the air contaminant level is exceed 100 ppm.
For the last part, which is the Gantt chart, we actually already reached the 11th week where the construction of the power and preparation for midterm critical design review, and we only got 4 weeks left before the presentation of the project, submission of the technical report, and final touch up.